Let's very quickly talk about linear regression. You're using this for data that is kind of linear. Like for example, when you're working, when the number of hours increase, your pay is going to increase as well. And that is a good linear regression. And maybe one of the easiest one that you don't even need linear regression for it, but just keep that in mind, okay? Because it's a very good example for linear regression. So as the number of hours that you're working increases, your pay increases as well. So you can draw it in two dimensions. You have X and Y, and on X you have number of hours that you worked, and on Y you have the amount of money that you made, okay? And then you will have a linear line between these two axes. And this, with this linear line, wherever you put your finger on any point of this linear line, it will, for example, show work hours, for example, 4 hours, and then the amount that you got paid, maybe like $200. You're making a linear regression, and you put your finger on any part of this line, and then you can go down and say, okay, you worked for what, 2 hours, and then you go to the amount that you got paid, and then you look at it and you're like, okay, so like $200. So right now, when 2 hours goes to $200, that means per every hour that you worked, you earn $100, okay? So you can write a very easy equation just based on this linear regression. Y is equal to 100x. That means if you have worked for 4 hours, you will replace your x with 4. 4 multiplied by 100, it will give you the y, which is 400, which is the amount of money that you make. So basically what linear regression does is just give you an algebraic equation. And then imagine you actually have a base salary. Either you work or you don't work. Like in an imaginary, you're gonna start with $100, regardless if you work or you don't work. And then after that $100, everything that you're getting is following this linear regression. So right now, as you can see, we are not starting from the 0 point. Your y-axis is not 0. Your y-axis is 100, okay? So now y is equal to 100. X doesn't work because you started from 100. And then after that, you keep growing. So if you're using the same equation, it's going to give you 400, but you're actually getting 500 because you have $100 added to this. So since you have a height, you're going to add it to this formula. So right now, y is not equal to 100x. Y is equal to 100x plus 100 because you started at 100. You don't start from 0. They pay you 100 no matter what. If you want to look at the general equation, this one you probably recognize, it's going to be y is equal to mx plus b. M is the slope of the line. B is where you have started. If you started from 0, if you started from negative, if you started from like positive 100 or anything that is going to be your b. So far we understood it is representing an algebraic equation. So now we want to figure out how does actually linear regression come up with these numbers. When you are creating, when you have these two axes, you just come up with a line, and then you are going to calculate how much mistake or how much error do you have between each one of these points and the line that you created. So yeah, you're using squared, you're squaring them because you don't want positive and negative cancel each other out, and then you will think that you have less error than what you actually have. So that's why you're using squared. You're moving your line until you get the least amount of error. That is going to be your equation. So keep in mind, the amount of money that you make with the hours, they have a complete linear relationship, but not everything. Like in real world, for example, the amount of cigarette that you smoke and how bad your lungs are, these are not they are linear equations. You can create a line in it, but it's not as perfect as it is. Every point that you have in your data set, it's going to affect how your line is going to look like. If you have a point, even if you have an outlier point, for example, if somebody's, for example, 15 years old and their height is 2 meters, that is going to be an outlier. So if you have something like that in your data set, it's going to change the slope of your line a little bit further up, and it might not, because it's trying to fit in that data point that is an outlier, and then it might throw off your calculation a little bit.